Hello everybody. In this video we're going to talk about the periodicity of elements in the periodic table, and by this we mean how the properties of the element is or depends on its location on the periodic table. And we will start by studying the elements in the same period. And to kind of revise what we mean by period, it is the row. So each row of this is called a period. We have 7 periods, 1, 2, 3, 4, 5, 6, 7. And each period, if you remember, corresponds to one energy level. So we have 7 energy levels and 7 periods. And for each period, if you take a look at the groups, you'd see that the energy level is the number of energy levels is the same, but we have the number of electrons increasing as we go from left to right. So we have here 1 electron, 2, 3, 4, 5 till we reach 8 at the outermost energy level. This is for period number 2. What we're going to talk about is the metallic and non-metallic properties, and what I'm going to talk about is the first two and these five columns, the five groups, which is 1A, 2A, 3A, 4A, 5A, 6A, and 7A. 8A is for the noble gases, and they are kind of special cases. They are totally saturated, they are very stable, so they don't contribute in what we're gonna talk about in this part. What we have here for the groups, that's 1B, 2B, 3B till we reach 10B. These are all gonna be discussed later in when we talk about the transition elements. They have special or different properties. That's why we're not gonna talk about them in this part here. So what we see here is that the again the number of electrons increase in the outermost energy level, and we want to see how the increase in the number of electrons affects the metallic properties and non-metallic properties of the elements. To understand what we mean by metallic properties, there are many ways to define the metal. So you can define the metal by it has a high electrical and thermal conductivity, that it's kind of shiny. You can define the metal by other methods. It's kind of malleable, it's not brittle. But the main way of defining the metals is that it forms positive ions. And for the non-metals, it's the other way. It forms negative ions. So usually metals can react with the OH group, which is the hydroxyl group, to make bases, and the non-metals react with the hydrogen ions to form acids. And this is what we know, like sodium hydroxide. Sodium is a metal, calcium is a metal, forms calcium hydroxide, magnesium forms magnesium hydroxide. And the other way, you can see that chlorine, you can have HCl, HF, and HBr. So these are all or react with hydrogen to form acids, and these react with hydroxyl group to form bases. So if we try to understand how the metallic properties change, so we know that these are acids, metals, and these are non-metals, and we would expect that or we know that this has very strong metallic properties, and this is because, as you see from this, there is only one electron in the outermost energy level, and it is making the atom not very stable, or very unstable. And this reflects on the behavior of the elements. You'd see that they want to become stable and get rid of this electron. That's why they go into reactions quickly to form the ion that is more stable than its current state. As you go to the right, you will have one more electron, and this getting rid of two electrons is more difficult than getting rid of only one electron, and that's why this can go into reactions, but not as easy as the sodium ions can do, or the first column. So as you go to the right, the metallic properties get weaker, um, and we would expect the same on the other side. Here you'd see that this is for chloride, or this is fluoride, I'm sorry. For fluorine, you would see that you have, no, this is fluorine. You would see that you have only one electron left in the outermost energy level to be saturated, and this needs to get this electron so that it is or it gets stable, and that's why it's kind of behaving the same way. But instead of getting rid of the electron here, it's trying to acquire one more electron, and that's why the reactivity of this group 7A is very high. They're very reactive elements, and it can react with anything to be stable. And you know that chlorine is a gas, Cl2, so it reacts with itself or forms a bond with similar atoms to form a molecule that is stable. Um, and that's why this is the kind of the most or strongest non-metallic properties will be here. And as you go to the left, the same thing as you expect would happen, that you have two electrons required, which is more difficult than getting or acquiring only one electron, and that's why this is a non-metal, but it's not as strong non-metallic properties as this, and the same here. So this is our conclusion, is that the metallic properties decrease. Again, I'm concerned with the A groups 1, 2, 3, 4, 5, 6, 7. So metallic properties decrease as you go to the right, and the non-metallic properties decrease as you go from the right to left. Um, you'd expect that there is kind of um, something in between that will not be totally metal and or totally non-metal. So this is a metal, this is a metal, this is non-metal, and this is non-metal. And as you go into the center, um, somewhere here you'd have something in between. It's not a metal, it's not a non-metal, and the properties would be kind of weird. I just want you, and this is the good thing about the current periodic table, or the one that you see here, is that it's color coded, and from the color code you can see that this kind of purplish color, it tells you that these are non-metals. This is called the halogens, which is this column. So you see that these are non-metals, and you see that this is the alkali metals, and this is the alkaline earth metals. So these two columns, and you'd see that these have different colors. And these colors is what I'm referring to now. There are some elements that are called metalloids, and these metalloids are or let's first go to the amphoteric metals. The amphoteric metals is a metal that is totally metal. It can have all the properties of a metal, but it can do or have some properties of the non-metals. So it's like aluminum. Aluminum is a metal. It can form aluminum oxide, hydroxide, and it is very conductive. It's very shiny. It has all the metallic properties, but it can form bases. Or react with sodium. So it can form sodium aluminate, which means that it reacts with metals, uh, so it's kind of non-metallic properties a little bit. So this is what we call the amphoteric metal. So it's kind of metal, but it's kind of hesitated a little bit. So we have aluminum, we have gallium, indium, tin, and these green colored elements are all amphoteric. There are other kind of elements that are in the border between metals and non-metals. It's like silicon, like boron, like germanium, and this is an element that has some metallic properties and some non-metallic properties. So it's not a pure metal, or it's not a pure non-metal. For the amphoteric metals, it was, sometimes they call it the basic metals. They are called they are metals but have some non-metallic properties. But in the case of the metalloids, they are totally in between. They don't have metallic properties as a whole or non-metallic properties as a whole. It's kind of in the border between them. So silicon, and silicon is the most famous one of them, and this is because silicon can behave as a metal, so it's conductive, and in some cases behaves as a non-metal and it's not conductive, depending on the voltage applied to it. And this is a very important property of silicon, and this is why silicon is very, very widely used in the electronics and in the manufacturing of the chips and making the ICs and all these components of the circuits in the circuit boards. And this is because it acts as a gate. You can turn the current on or off in specific parts of the circuit, so it can act as a gate, and that's why it is very widely used in the electronics industry. And this is because this property, it can be behaving as a metal or as a non-metal. So now the elements can be split into either metals, non-metals, metalloids, or amphoteric metals. And this is something that we can see in the sodium till chlorine. This is the this period. And you see that sodium hydroxide is strong base, magnesium is a weak base, aluminum is an amphoteric base, and then you turn into the weak acid, which is the hydrogen silicate. Then phosphoric acid is strong acid, sulfuric acid is a very strong acid, and then you'd see that the hypochloric acid, this HClO4, is the strongest acid of them. So these are the change of the properties from very or high metallic properties to high non-metallic properties. And the same would be applied to the chemical reactivity. Again, if you see what we mentioned before, this is very reactive. It can easily get rid of the electron. This is very reactive. It can easily this can easily acquire one electron, and it gets weaker as you go into the center. So the chemical reactivity decreases from here to the center and from here to the center. So this is all for this video. In the next video, we'll talk about the periodicity of elements in the same group. So I'll see you then. Goodbye.